You lock down your endpoints. You filter for all egress data. You installed malware detection tools, and still you're leaking data. How could this happen? There is a technique called data bouncing, and that's what we're going to discuss today in Threat Talks The Deep Dive. So let's get on to it.
Welcome to Threat Talks. Let's delve deep into the dynamic world of cybersecurity.
Today with me is Luca Cipriano,
Hey.
Our CTI and Red Team Program Lead. Welcome to the show.
Thank you.
So he came to me, I have this technique called data bouncing, and it's going to make my life as a defender really, really hard.
It gave you a headache at a certain point also, right?
Yeah, I was really curious. So I'm very glad we're going to do this topic. Can you tell me and the audience, before we continue, there is also a video demo that Luca is going to give us on data bouncing. So for all our listeners, Luca is going to talk us through it. So if you're in the car and don't have a screen ready to look at it, don't do it. But if you want to see what Luca is actually doing, then later on, tune into YouTube and you will see all the comments and all the things that he's doing and explaining to us during this episode. So, Luca, what is data bouncing?
Yeah, so data bouncing is a technique that can be used to exfiltrate data in a stealthy way. So let's assume I'm an attacker. I'm on your computer already, and I found a really important document that I want to get, like for example a PDF, and I want to exfiltrate it without the SOC or any alert to be triggered or the SOC being alerted. So what I can use data bouncing for that. So data bouncing is a sort of exfiltration. In this case, we're going to use DNS request to exfiltrate data. And we are going to exfiltrate data through a third party. So when you send HTTP requests to a website, your request will contain several headers. And some of these headers will contain a domain. Like for example, there's the header x_4. It's a header that is used to get the origin of the request. So if I am sending a request to a website like hp.com, which is the example that we're going to see here, and my traffic is going through a load balancer or a proxy, the source that they will see is the load balancer or the proxy, and the x_4 header will be the original origin, so the hop before the proxy.
This one is often used for example, for geo IPs.
Yes.
So if you go to a website that runs in the cloud and you're located in a country, then the website will display, or at least tries to display, your home language.
Yeah, indeed.
And the idea here is if you're behind a proxy, it will always display the language where the proxy is located instead of your own language.
Yeah, so that's why you look at the _4. And in order to do that, they need to resolve the domain where I'm coming from. So they will have to send a DNS request and resolve it. The same things happen, for example, for the referrer. So if, for example, I visit a web page from another web page, the referrer will be the original web page where I'm coming from. And some of the website, they will resolve the content of these headers for, as you mentioned before, the
geolocation.
The geolocation, yeah, exactly. Or some analytics, or they want threat intel or data, so they will resolve it.
Mm-hmm.
And data bouncing will abuse this functionality to exfiltrate data. So what happened is, I wanted that PDF that we discussed before. Mm-hmm. So I'm going to convert that PDF in base 64. I will divide the base 64 in chunks, and I will add those chunks as a subdomain of a server that I control. And I add each chunk to the header that will be resolved by the third party. So when my server that I control will receive that request, I could retrieve all the pieces of the base 64, all the base 64 chunks, recompose it, and get the file back.
Yeah. So
and all this via the third party.
Yeah. So as a small recap, first you're already in the network.
Mm-hmm.
You find some data that you want to exfiltrate, and then that's where data bouncing kicks in as a solution for that.
Yeah.
And then what you will do is you will send requests to a third party, so outside of the company you're in as an attacker.
Indeed.
And it could be hp.com, but probably also any other big website.
Yeah. There's plenty. There's several.
Okay. And you connect to them, and you send within the headers of your request the data. Yeah. And then because those servers are going to do a DNS lookup.
Yes.
That probably at your DNS server then.
I will receive it.
Yeah, you will receive it.
Yes,
okay.
Indeed. So for the demonstration, I'm going to use two hosts. So the host on the right is an attacker. So it's my attacker, and it is outside of the office network. So it's on a separate network.
This is the moment where the video starts playing. So for the listeners, if you want to see it as well, but we will guide you through it. But
I will guide them through it. So I'm going to use two hosts, one attacker, which is outside of the network, and a Windows victim, which is inside of the company network. So we assume that I have already initial foothold on the Windows host. So I'm going to use Interact.sh for this demo, which is a tool that it can be used to. It's used for out of bound testing. So you will spawn a server that it listens for HTTP and DNS incoming HTTP and DNS requests on the web, and I can see the logs in the backend. This is used, for example, in web application pen testing. If you want to see if you have, for example, remote code execution on an application, but you can't see anything from the application itself, you then try to trigger a request to an out-of-bound service. So then you will see that you received the request, and you know that your
and this tool, Interact.sh, is a tool that anyone can just download.
Yeah, you can just download it. Anybody can download and use it. It will spawn a domain which is a string.host dot something like pro or fun. And as you can see, this kind of domain are known, so they get blocked. If I try to visit it internally from the host that is in the network, we can see that the policy on our firewall will block me visiting the website because it's seen as a command and control traffic. Because these tools, they are used also by attackers. They're legitimate tools, but they're used by attackers. So if you can see directly, I can't visit it. But now I will show how you can visit it from using the header, as I explained it before. So for this, we're going to use another tool, which is called Burp Suite, and it is a proxy to intercept web traffic. So I can use the I can use the Burp Suite browser and the intercept function, and as soon as I try to visit a website, my request will not go directly, but it will be blocked, and it will be blocked by Burp Suite. And before sending it, I can change it and interact with it. So as soon as I visit a website, like in this example, we're going to use hp.com, you will see that I can't visit it because Burp Suite is intercepting it. And in the history, I can see the pending request. Request. And then I can send it to the repeater. And from there, I can modify it before sending it. The repeater is a tool that will allow me to send this request as many times as I want, modified every time. So what I'm going to do, as we explained it before, as you can see in the request, there's a lot of headers here. I'm going to add an extra header. This header is the X forwarded for, because that's what it works now for hp.com. I know that they resolved this. And I'm going to add a secret message, which is going to be appended as a subdomain of my .host domain. So I'm going to write secret message.
This is purely to verify that the host will do the lookup for you.
Yes, exactly. So as soon as I send this header, we need to wait a little bit, but you will see that Interact.sh will receive my secret message.
Yeah, so what happens is you will send it to the host, you intercepted it, edit your domains, and once the host receives the message, it will do a lookup up on domains, and that will show up in Interact.sh.
Exactly. So, and as you can see here, I can see from the logs of Interact.sh my secret message .the domain. So this is, as you can see, we couldn't before from this host visit host.com, but now with this technique, we are allowed to.
Yeah, because you're allowed to go to hp.com.
Exactly. So this is the technique that is used to exfiltrate the data.
Yeah, and also in this sense, a way to check if a host is doing those lookups.
Yes, so there are plenty of those, and of course they don't do only X refer from, but they do this with several headers, so you can create easily, and also there are already online proof of concepts. You can just get scripts, or you can put a list of domain, and they will test all the headers, and you will just have Interact.sh open next to you, and they will see which are all the domains that will resolve the headers, and it will tell which headers are resolved. So now for the it's a bit more clear, hopefully, for everybody. But now for the practical explanation. So as I mentioned before, I'm on this Windows host. I'm the attacker. I'm there, and I want to exfiltrate a file. I want to exfiltrate this file on the desktop, which is called secret.
It sounds like a secret file.
It's a super secret file. So the first thing that I'm gonna do, as you can see, my folder is empty. I'm gonna start the attacker folder is empty. I'm gonna start Interact.sh client, which will generate a new domain. So now this is my listener. I can wait for it. I can look at the logs from here, and then look at the content of the secret.txt. It's just a small file. It's a part of a lorem ipsum. I made it really small because, of course, I need to recompose the chunks manually and I didn't want like a blob of base64. So for the sake of this demonstration, it's just a small piece of text. And to exfiltrate it, I already moved a PowerShell script, which will take the file, as we mentioned before, convert it to base64, divide it in chunk, add the identifier of the computer, just in case you have more, and it will say chunk 1 out of X. In this case, there are 3 chunks, so it's going to be 1 out of 3, 2 out of 3, 3 out of 3, because then I need to recompose it. And these requests, sometimes they don't come in the correct order, so I need to be able to understand which one is the order. And it will send the request to hp.com using the x-forwarded4 header. So at this point, I just need to open a shell. In this case, I need to use PowerShell with I need to use execution policy bypass because otherwise I can't run my script, which is something that a user shouldn't normally be able to do.
It's one of the things to block it.
Yeah, indeed. But this is just a demo. You can do it in a lot of different ways. So I'm going to use the script. I'm going to select my script, and then I'm going to select the file, and then I'm just going to need to paste my .host domain, and just press enter and wait. So at this point, as you can see, I started to get requests. So I have the identifier and chunk 1.3 and all the chunks. So I get the second one, and then I get the third one. So at this point, the last thing that I need to do is just recompose all the pieces of the base 64.
Yeah, you merge them together.
Merge them together, yeah. So for this demo, I will do it manually. You can do it scripted, of course, if it's a really huge
you get a lot of DNS requests, so there's a lot of things to merge.
You can make just a script to do that. So at this point, the only thing that I need to do, I can, for example, use echo and recompose all the parts of the base64, and then I can just pipe it into base64 decode, and then output it in secret.txt, which is the file, secret.txt. And press enter, and then as you can see, it's on the folder now that was first empty. So it's really easy. If I open the content of secret, is the lorem ipsum, and I can use cat to look at the content of secret.txt on my folder, and as you can see, it's the same content. So of course, this is a small demo just to let people understand, or let you understand, and everybody how you could exfiltrate data. But you can imagine that if I'm an APT, like a state-sponsored attacker, and I have plenty of time, with this method, I can exfiltrate really big files. And I can also do it with a delay, so I don't need to send all the chunks at the same time. And I can use different websites with different headers.
The nice thing I would say for an attacker, from the attacker perspective, is as an attacker, you don't have direct access to your your host where you receive everything, you always put this man in the middle there.
Yes.
So HP.com, maybe even Microsoft.com or any other big website. And if I look at the traffic log, I won't see anything suspicious.
No, you will see just traffic that might be legitimate. And even worse, if you don't use decryption, you are not even able to look at the headers that are in the packets. So this is going to be totally hidden from you.
Yeah, that's a nice bridge, because the question now arises, how do we defend against this?
Indeed. So that's quite difficult to prevent and also to detect. So I want to start from probably what is a bit less easy, let's say. You as a third party, probably, do you really need to resolve all these headers? Is it something that is really needed? So you should consider, because you could be used to exfiltrate data. And I mean, I don't know, do you really need that? What do you think?
It's hard for me to determine if a third party really needs to look up the domain names. But what I don't like, at least, of this solution, is that I'm dependent on those third parties. If they implement, maybe not implement, but block the DNS lookups for the headers.
Yeah, and indeed. So there's not something that you could do. What we mentioned before, one of the things is like apply decryption. There's, for example, Palo Alto as an option which will strip the X forwarded 4.
It's mainly there to prevent your internal IPs from being leaked.
Yeah, but it can be used at least to strip one header. But again, you need decryption, because otherwise you can't.
Yeah, that's good to mention here, because all those headers are, of course, if you go to an HTTPS web server, are all encrypted. So you need decryption in order to see these headers.
Yeah, exactly. So that's already something you can look at.
So it's using a feature that is meant for something else, but can help here.
It can help here. Okay. Yes. Of course, it's not only the X forwarded 4. There's more headers. But if you have deep packet inspection and you can look at the headers, you could, for example, try to use some sort of machine learning or try to detect a sort of randomly generated domain.
Palo Alto Networks already has this feature. It's in part of the advanced DNS security, where they can figure out if domain-generated algorithms, domain names, DGA, are being used by malware to spin up a lot of domains. So they can already detect that, and I think your domains will look more or less the same. So I can imagine if they will do the same technique for those headers, that they might detect that this data bouncing is being used.
Probably it will alert at least. But these are like some sort of alerts that you could have. And also you can set up custom alerts if you are in a place of the network where you can inspect this. So it does not need necessarily to go at from the firewall, or maybe you can have your own way of preventing with custom alerts on logs that you ingest.
Another defensive measure I think you can take is just lock down your machines. Not every machine needs to be able to talk to any website. So if an attacker has access to a server, which is already bad, but then at least make it more difficult so that the server is not allowed to communicate directly to the external world, only to what's really needed.
Exactly. It depends on which machine you are from, because if I'm on a host from a user, it's going to be difficult.
Then it's going to be difficult.
Because I assume the IT department will receive a lot of phone calls that the people can't visit.
What might be good to mention again here, you're already in the network, and we already have a few steps before that. If you look at the kill chain, you're now acting on the last part, acting on the objective.
Yes.
There are a lot of steps before that, before you're in the network, where we can take a lot of measures.
Indeed.
Make it really hard for you.
Let's try not to have the attacker reach the point where it can exfiltrate the data.
So that might be a good moment to go to the call to action for our listeners. Is you can test it easily yourself. So Luca showed us how you can test this. You can run Interact.sh, as you mentioned, with the Burp Suite. Burp Suite is also free?
Burp Suite is free, yes. You can have the community edition. You can use the sort of Interact.sh within Burp Suite, which is called Collaborator. But for that one, you will need a pro license. So, but I mean, you can use Interact.sh.
Yeah, and then you can simply test if you can detect it with your current security tooling.
Yeah.
I think that's a good thing to do. So check it on your company. Check if you can leak your sensitive data. Don't do it with actual sensitive data, but use some lab files or dummy files. But it might be good to be aware of this technique, data bouncing, and if it can be used within your company. So as a conclusion, I think we both can agree here that data bouncing is really effective. It's really hard to block.
Yes.
We have some countermeasures, but still you can work your way around it. And like you said, if you're an APT and you have enough time, they do it really, really slow.
Yeah, you can take your time and send, as I mentioned before, a call every hour and use different domains with different headers. So
so it's really hard to stop. But in the end, it's the last step as an attacker. So hopefully you can already prevent the attacker from coming this far. So if you look at the kill chain, we have a lot of options to stop the attacker before he comes to the data bouncing. So with that, I think it's a nice ending of the show.
Yeah.
We show data bouncing, how it works. To you listeners, if you liked what you saw or just maybe only heard, just press like and subscribe and you will be updated when the new episode next week is being released.
And since this was once the first time we're doing this, maybe let us know if you like to see more hands-on techniques. If you liked it, we can do more.
Let us know, and I hope to see you next time. Thank you.
Thank you for listening to Threat Talks, a podcast by Onto It Cybersecurity and AMS-IX. Did you like what you heard? Do you want to learn more? Follow Threat Talks to stay up to date on the topic of cybersecurity.